Aloha champions, and welcome back to this Friday edition of our CK Science video. Today we are going to be wrapping up Unit 4, all about geology and the processes that shape our Earth. So we've gone through learning about tectonic plates and how they move the crust. That's that bubbling mantle in the middle of our Earth, kind of moves all that molten magma that will eventually erupt from volcanoes as lava. We've learned how earthquakes and tsunamis and erosion are all formed. And we've learned about 3 types of rocks: igneous, metamorphic, and sedimentary. So it's been a big chapter, and we will come back to more geology. There's a whole CKLA unit that we get to Unit 6, so that should be end of 3rd quarter or in 4th quarter that we'll be working on that. But for today, we are on Chapter 7, talking about landslides. So without further ado, let's get into today's reading of Unit 4, Chapter 7, landslides. First thing that my eye gets drawn to every time that we read a science book is my big questions and my vocabulary. So, big question: how can communities prepare for landslide hazards? We've talked about how communities can prepare for erosion, the threat of tsunamis, the threat of earthquakes, and the threat of volcanoes. Now, how do we respond to the threat of landslides? Okay, our vocabulary term is landslide. What is a landslide? Well, a landslide is a form of mass movement in which a large section of a slope slides downhill all at once. So erosion is small movements of sediments from one place to another. A landslide is taking all those sediments and just dropping them down a slope or hill all at once. Okay? A mass movement, one of those terms used here to describe what a landslide is a downhill movement of mass of Earth surface material. Okay, so mass movement. It has weight or mass to it that we can measure, and it's moving downhill. Okay, so without further ado, let's learn more about landslides. The Latoya Bay, Alaska tsunami of 1958 began with a magnitude 7.9 earthquake. So remember, tsunamis can be a result of an earthquake. The earthquake then caused a landslide. Well, some 30 million cubic meters of rock slid into the bay, a bay of water, and this displaced a huge volume of water. The tsunami, a third of a mile high, crashed up onto the slope at the head of the bay. The tsunami swept away thousands of trees. It's a huge wave, a third of a mile high. To estimate what a third of a mile is, if you walk the entire perimeter of the fence at Paideia, you are doing a quarter of a mile. So add a little bit more to that. That is massive of how high that is. It's almost 2,000 feet tall. If there's 5,780 feet in a mile, 2,000 feet tall is a huge wave, all caused by this landslide of Earth falling into the bay and creating this wave. Okay? A rock slide is a type of landslide. A landslide is a form of mass movement, which is a downhill movement of sediment and other earth materials as one big hulking mass. Unlike a mudslide, a landslide involves relatively dry material, such as sand or rocky sediment, larger rocks, or dry soil. A landslide occurs in a matter of moments. It is usually triggered by an earthquake or extreme weather. Because a lot of heavy, hard material moves all at once, landslides can be extremely hazardous. What causes landslides? There are many causes for landslides. On the previous page, you learned how an earthquake triggered a landslide and a tsunami, but there were other major causes as well. In 1980, a volcano in the state of Washington erupted. Mount St. Helens, as it was called, is part of the Cascade Mountain Range. It exists along the Ring of Fire, a line of volcanoes that are located where Earth's largest plate, the Pacific Plate, meets other plates. When the volcano erupted, the side of the volcano collapsed. This displaced 2.8 cubic kilometers, or 2/3 of a cubic mile, of dirt, rock, and other debris on its north side. So this was once a volcano, and after it erupted, all that land on the north side just collapsed and slid, moving a lot of rocks with it. There were many smaller communities around the volcano. Most of these cleared out before it erupted and the landslide occurred. That's because the eruption was predicted by 2 months of smaller seismic activities, smaller earthquakes. The tiltometers were like, hey, something's happening. Maybe we should get out of here. Remember that seismic activity is another term for earthquakes. All those little tremors, they're like, we should go somewhere. This doesn't seem safe for us. When there are movements in Earth's crust, seismic waves are sent out. There are many ways for scientists to detect seismic waves and earthquakes. Because of this, it is also possible to predict approximately when a volcanic eruption and any landslide associated with it might occur. Because scientists could tell that Mount St. Helens was about to erupt, they were able to issue warnings. They told the people and communities around the volcano to evacuate, to get out of there. Most people did. But still, between the earthquakes, the eruption itself, and the massive landslide that followed, much property was destroyed. Many organisms were also killed by the natural hazard. So here we've got the forest that was sitting on top of that 2.8 cubic kilometer land. All those trees that were on top of that, they just got buried under earth. Okay? Gravity can cause landslides by pulling down on dirt, rock, and debris on a slope. Water can also contribute to landslides. It can get into rock and freeze. Over time, this can cause the rock to break apart and erode, leading to a possible landslide. Where there is little vegetation, water can cause the ground to turn muddy. If on a slope, it can then become a type of landslide called a mudslide. In December 2017, a large fire destroyed dry vegetation around Montecito, California. Called the Thomas Fire, the fire quickly spread over 202,000 acres of land. When the fire was over, California experienced a lot of rainfall. Most of this land was made up of hills with very little vegetation holding the ground together. The land on the slopes became muddy, and because it sat on a foundation of rock, the mud soon began to move and slide. This mud also carried large rocks and boulders with it. These presented a danger to people in the area. Homes and other property were destroyed in the mudslide. Here's just that river of mud just sliding through into all these nice houses up on this hill. Okay? So, evidence. Where do scientists find, or how do they research landslides, and what's our possible solutions? How can communities better cope with the possibility of landslides in the future? That big question. Okay? Can we predict landslides? Well, visible evidence of erosion, such as new boulders at the base of a slope, can be a warning sign. Tilting trees or other objects, including poles, can indicate that a slope is about to give way. So here's some natural solutions. One way that some communities have tried to solve the problem of mudslides and or landslides is to plant more vegetation, more trees, more plants, thicker, sturdier roots in the ground, the less that is going to move. Some types of vegetation have roots that grow deep and strong in the soil, causing the soil to cling together. This makes landslides less likely, but events such as wildfires followed by a heavy rain can clear an area of vegetation and make it more likely that landslides will happen. In some areas, people have built walls or terraces on hills to make landslides less likely. Some human-made solutions to the problem of mudslides and landslides. Communities that are vulnerable to landslides can reduce some of the hazards that they face. A home that is going to be built on a slope can be protected by having a retaining wall above and below the house. These walls change a steep slope into something more like a staircase. Each level holds a certain amount of sediment. Another technique is to use concrete and steel pillars to support hillside structures. These pillars can be anchored into solid bedrock, so the structures are more likely to stay in place, even if the looser sediment tumbles down the slope during a landslide. The foundation remains anchored to the part of the Earth's surface that does not collapse. However, it is possible that the debris flow could crash into the structure and knock it off its secure foundation. So I've said this before, but when it comes to geology and Earth changing over millions and billions of years, Earth's going to do what Earth's going to do. If the rock or mud isn't secure, it's going to slide down. If you've got those fault lines and they're pushing against each other with all that pressure, you're going to wind up with an earthquake. If that earthquake happens to be underwater or near the water where it can drop a whole bunch of land into the ocean and create a third of a mile high, 2,000 feet tall waves, Earth's going to do what Earth's going to do. Only thing we can do is try our best to prevent the outcomes of such things. And we've thought of this with our big questions for the last 4 or 5 parts of this chapter. We can measure, we can find our evidence, we can make predictions, we can build in certain ways to try to keep our buildings strong and better, but ultimately we can't 100% stop Earth from doing what Earth's gonna do. There's just simply too much Earth to stop it. We just have to be able to listen to our scientists, listen to those people who are running the seismometers to read that seismic activity to make sure that we try our best to prevent any major incidents or loss of property or loss of life from happening, but we can't always stop it. But this will conclude this time talking about geology. As I said, we do have another unit in CKLA where we do go through geology, give you a refresher on everything near the end of the year. So hopefully everybody had fun with this. Hopefully everybody enjoyed doing those volcano projects that we did before we went on break. And with that, I look forward to our next science topic. I can't remember what it is off the top of my head, but we'll start those videos next week on Tuesday. So thank you, stay awesome, and I will talk to you real soon.